Dear students, today we are going to start with a very important and advanced concept in artificial intelligence called explainable AI. And before we go deep into a technical aspects, I want you to think in a very simple way about how you use technology in your daily life, because every day you are interacting with the intelligent systems, whether you realize it or not. When you open an app like Instagram, or when you shop on platform like Flipkart, you see recommendations appearing automatically. And most of the time, you just accept it without questioning. But if I ask you, why did that particular recommendation come to you? You will not able to answer clearly. And even the system itself cannot explain it in a human understandable way. And that is exactly the problem that explainable AI is trying to solve, because the traditional AI models, especially deep learning models, are very powerful, but they behave like a black boxes, meaning they take input and produce the output, but the reasoning inside the hidden. And in earlier days this was acceptable because the accuracy was the main goal. But now the things are changing, because AI is being used in sensitive areas like healthcare, finance, and law. So where the decision directly affect the human lives. So we can't just rely on the accuracy alone. We need transparency and trust, and that is why researchers um, are shifting from just building to predictive models to building explainable system. And in the future, the focus will not be only on what the model predicts, but also on why it predicts and how it predicts. And this shift is very important because the user, developers, and the governments all demand accountability. And the students, you should understand the explainable AI. There is no universal framework yet. Different researchers follow the different approaches, and that creates an inconsistency. So future research is focusing on standardization and also integrating the ethical considerations into the AI system. And another important point is usability, because an explanation is useful only if a human can understand it easily. So the goal is to design the explanations that are not only technically correct, but also meaningful to users. And as future engineers, you must think beyond the coding models and start thinking about the responsible AI design. Because tomorrow, when you build a system, the people will not just does it work. They will ask, can you explain it? And that is where explainable AI becomes the foundations of trustworthy in intelligent systems. Now let us move to the next important concept, which is the need for formalization in explainable AI. And here I want you to understand a very critical issue that exists today. Currently, when we generate explanations for AI models, most of the time we evaluate them informally, meaning we look at the explanation and say it looks reasonable or it seems correct. But this is not scientific, because in engineering we can't depend on the assumptions or visual satisfaction. We need measurable definitions, just like when you write an exam, your performance is measured using the marks. Similarly, the explanation must also be measured using proper metrics. And that is why future research in explainable AI is focusing on mathematical formalization, where we define clearly what makes an explanation good and some important properties, fidelity, and then interpretability and causality. So fidelity means whether the explanation, right, whether the explanation truly present the model behaviors. Interpretability means whether a human can understand it easily. And causality means whether the explanation correctly shows cause because and affect the relationship. And let me explain this with the real-time scenario. Imagine a bank using AI to approve or reject loans. If a customer's application is rejected and the system simply says rejected, that is not acceptable. The customer will ask why, and the system must provide a clear and measurable explanation, such as low income stability or poor credit history. And not only that, the explanation must be consistent across the different cases and also it should be verifiable, which means if we check the model's internal logic, it should match the explanation given. And the students, this is where formalization becomes more important because without proper definitions, we can't compare different explanations methods and we can't improve them systematically. And the future system will include quantitative measures. So where we can assign the scores to explanations just like a accuracy score for models. And this will help the researchers and developers or students to build the better and more reliable AI systems. And another important aspect is that formalization. The formalization will help in building trust and because when the explanations are backed by mathematical definitions, the users feel more confident in the system. And as a future professionals or researchers should understand that explainable AI is not about generating the explanations, but about ensuring those explanations are valid, reliable, and measurable in a scientific way. Okay, students, now let us discuss another major challenge in explainable AI, which is benchmarking and the evaluation. And this is a very important area because without proper evaluation, we can't say which method is better. And currently, one of the biggest problems is lack of standard data sets. Specifically, it designed for the testing explanation. Different researchers use a different data sets and the different evaluation techniques and because of that results are not comparable. One model may perform the well one in data set while another performs well in the another data set. But we can't include which one is actually better. And this creates a confusion and slows down progress in the field. So the future direction is to create standardized benchmark. The datasets dedicated to the explainable AI. And these datasets will include not only input data and the output, but also ground truth explanations. So that we can compare the generated explanation with actual expected explanations. And let me give you a real-time example. Consider the autonomous vehicle when a self-driving car make a decision such as stopping or turning. It should be able to explain why it made the decision. And if different companies develop a different explanation, we need a common benchmark to evaluate them fairly. Otherwise, one company may claim their system is better without proper proof. And benchmarking helps in ensuring fairness and consistency. And it also helps in identifying the strengths and weakness of different approaches. And in the future, we will see the datasets like explainable image datasets, where the models not only classify the images but also provide the reasoning, and explainable text datasets, where the models justify their predictions in a natural language. And this will help the researchers to develop more robust and reliable explanation technique. And students, you should understand that the benchmarking is not just about the testing, but about the creating a common platform where innovation can be measured and compared. And this will accelerate the growth of explainable AI and make it more practical for the real world applications. This is also I explained. Now, the students, let us move to the very interesting and important trend in the explainable AI, which is the shift from post-hoc explanations to inherently interpretable models. And earlier, the approach was build complex models, deep neural networks, and then try to explain their outputs using the additional techniques. But this approach has the limitations because the explanation may not always accurately reflect, okay, then internal behavior. And that is why researchers are now focusing on designing models that are interpretable from the beginning, which means the model itself transparent and its decision making process can be understood directly. And the examples of such a models include decision trees, rule-based systems, and the generalized additive models. And let me explain this with a real-time scenario. Consider a healthcare application where an AI system to predict the risk of disease. If the system uses a deep learning model, it may give a prediction, but not a clear explanation, and the doctors may not trust it. But if the system uses an interpretable model, it can clearly show the factors and contributing to the prediction such as age, blood pressure, and cholesterol levels. And this make it easier for doctors to understand and trust the system. And the another important trend is the development of hybrid models that combine the strength of deep learning and symbolic, where deep learning provide the high accuracy and the symbolic AI provide the clear reasoning. And this combination allows us to achieve the both performance and explainability. And the students, this is a significant shift because instead of treating explainability as an afterthought, we are making it core part of model design. And this will lead to more reliable and trustworthy. And as a future engineers, you should focus on the building models that are not only accurate but also interpretable. Because in the real world applications, the explainability is just important as the performance. We will see the next slide. Students, now let us explore the concept of interactive explanation, which represent the future of how the human will interact with the AI system. And currently, the most explanations are static and meaning. A system provide a fixed explanation. It can't be changed or explored further, but in the future explanations will become interactive, allowing the users to ask the questions and receive the detailed responses. And this will transform AI system from passive tools into active collaborators. And let me explain with this simple example. When you use an app like Instagram, you see the content recommendations, but you can't ask the system why a particular post is shown to you. In the future, you will able to interact with the system and ask the questions like, why did you recommend this? And what would happen if my preferences were different? And the system will provide the meaningful answers in natural language. And this type of interaction make the system more transparent and user friendly. And another important application is in healthcare, where the doctors can interact with AI systems to understand the reasoning behind the predictions. And instead of just seeing a risk score, they can explore the contributing factors and their impact, and this will improve the decision making and the patient outcomes. And the students, you should understand that interactive explanations require advanced techniques. Okay, these advanced techniques such as like natural language processing and the visualization tools. And they also require the models. They can generate the explanations dynamically based on the explanations, based on user queries, and this is a challenging but exciting area of research. And in the future, AI system will not just provide the answers, but will engage in meaningful conversations with the users. And this will make a more accessible and trustworthy. Okay, for example, in a healthcare, the doctors won't just see it is a risk score. They will see a reasoning path and confidence level. Okay, so the human AI collaborations is a very important. It's a more accessible and trustworthy too. Okay, now let us discuss the role of regulations and ethical considerations in the future explainable AI. And this is becoming increasingly important as AI systems are being used in critical areas that affect the human lives. And the government and organizations are recognizing the need for transparency and accountability in AI systems. And for example, sorry, and as a result, the new regulations and the standards are being developed to ensure that the AI systems are fair, unbiased, and explainable. And for example, in sectors like healthcare, finance, autonomous vehicles, and law, it is essential that AI system provide the clear explanations for their decisions, because these decisions can have significant consequences. And let me give you a real-time example. If an AI system denies a loan, the applications or rejects an insurance climate must provide a clear explanation. Otherwise, it may be considered unfair or even illegal too sometimes. And organizations like Google and DARPA are actively working on the developing of frameworks and programs for explainable AA. Okay. And regulations such as EU Act are setting standard for trustworthy. The AA systems and these regulations require AA system to be transparent, accountable and aligned with the ethical principles. And the students, you should understand ethical AA is not just technical requirement, okay, but also the social responsibility. And as a future engineers must ensure that the system you build are fair and do not discriminate against individuals or groups. And this requires careful design, testing and evaluation AA systems. And in the future compliance with the regulations will be a key requirement for deploying the AA system in real world. And this will drive the adoption of explainable AA, that AA systems are used responsibly, right? So the two organization to create the framework, don't forget that Google Spare and the DARPA XAA. Finally, let us discuss overall vision of the future explainable AA. And this is where we bring together all the concepts we have discussed so far and understand the ultimate goal of this field. And the vision is to create AA systems that are not only intelligent but also trustworthy, and which means the systems can the reason, justify their decision, justify their answer, and communicate their logic in a way that human can understand. And in the future explanations will be formalized using the mathematical definitions, ensuring that they are accurate and reliable. And they will also be fair and meaning they do not introduce bias or discrimination. And they will consistent providing the same reasoning for similar situation. And they will acceptable, they will be actionable, helping the users make informed decision. And let me give you a real-time scenario. Consider a job requirement system that uses the AI to screen candidates. Instead of simply rejecting the candidate, the system should provide a clear explanation, such as lack of required skills or experience. And this helps us the candidate to understand the decision and improve in the future. And it also ensures that fairness in the recruitment process. And the student, this is kind of impact explainable AI can have on society. And it will play a crucial role in the building trust between humans and the AI system. And as AI continues to evolve, it will become the more integrated into our daily lives. And the need for explainability will become even more important. And as a future engineer and a researcher, you have the opportunity to contribute this field and shape of future of the AI. And remember that the goal is not just to build the system, but build the system the people can trust and rely confidently. Okay, final our end goal is trustworthy AI ecosystem that a human can rely on confidently. Clear? Dear students, now let us understand explainable AI using real-time case study from the healthcare domain, because this is one of the most critical areas where the AI decisions directly impact the human lives. And here, explainability is not optional but a mandatory. Okay, so the imagine a large hospital implementing AI system to predict whether the to predict to predict whether the AI decisions directly impact the human life, right? And also the system predict whether the patient is at high risk of heart disease, and this system trained using thousands of patient records including age, blood pressure, cholesterol levels, and lifestyle habits and medical history. And after training the model, they become the more highly accurate, and when a new patient come into the system, it predicts that the patient has a high risk of heart disease. Now, if this was a traditional black box AI model, it would simply display a result saying high risk. And the doctor would be confused because there is no explanation behind the prediction. And the doctor cannot blindly trust the system, especially when a human life is involved, and the patient will also ask why they are being diagnosed as a high risk. Without proper explanation, this creates a fear, confusions, and mistrust. So this is where explainable AI comes into the picture. And now the hospital upgrades the system using XAI techniques. And when the same prediction is made, the system does not just go the high risk, but also provide the detailed explanation, saying that the prediction is based on the high blood pressure, elevated cholesterol levels, and the family history of heart disease, and it also show the contribution percentage of each factor. For example, blood pressure contribute 40%, cholesterol contribute 30%, genetic history contribute 20%, and now the doctor can clearly understand the reasoning behind the prediction and can verify whether it makes a sense medically. And the doctor can also explain this to a patient in a simple language. And the patient now feel more confident because the decision is transparent and understandable. And the students, this is the first level of explainability, where we move from the black box output to interpretable reasoning. Now let us go to the one step further into the future, where the, where the system became interactive, and the doctor can actually ask the AI system questions like why is blood pressure given more importance than cholesterol, and the system respond by showing the past data patterns and correlations, and even suggest what would happen if the blood pressure is reduced. And this become a dialogue between doctor and AI system. And this is the future directions we discussed earlier, where the explanations are not static but interactive. And now let us connect this is to formalization, because the hospital cannot just relay the explanations that look the reasonable. They need the measurable assurance that the explanations are correct. Okay, so the system included the metrics like fidelity score, which ensure the explanations truly reflect the model's behavior, and the interpretability scores, which measure the how understandable the explanation is to doctors. Okay, hope you clear.